We are moving from a system of general medicine, and Swami Ananda and I were just at a conference in San Diego a few days ago talking about this. We're going to move from a system of general medicine to personalized medicine. And so general medicine means you have a headache and you take a Tylenol. Personalized medicine means that, well, before you take a Tylenol, you check with your genome to see whether you're one of the people who may die from taking a Tylenol, and it's good to know that. And any drug that you take, with lots of cancer medications, have 30% efficacy. That means 70% non-efficacy taking these poisonous drugs into our bodies. And it will be malpracticed to experience general medicine when it will be possible through your genetic code and algorithmic medicine to understand who you are, what kinds of medications, what kind of treatments, what kind of foods you will best respond to. So we'll have millions, hundreds of millions, and ultimately billions of people who will have their genomes sequenced. And what will that mean? Well, we'll have billions of sequence, and we'll have billions of examples of how people experienced their lives. How tall were they? How old were they when they got some genetic diseases? What kind of genetic abnormalities did they have? What was their IQ? And through all of these things, we will move from understanding single gene mutations, which are relatively rare, where there's an on-off switch, to much more complex polygenic traits, polygenic diseases like type 1 diabetes and coronary heart disease, but also polygenic traits like height. There's not one height gene. You're not tall because you have a neck like a giraffe. You're tall because you have a bunch of things that are tall. And intelligence, and many, many other things. Anything that has a genetic foundation, we are going to understand pretty well. And so what does that mean? Well, when you go back to IVF and embryo selection, and when you're screening those early stage embryos, rather than just knowing those few things that I mentioned before, we're going to know a lot. And so people will be able to select out genetic diseases, and we will very quickly eliminate many genetic diseases. And then to select in jurisdictions where it's legal and people are comfortable with that. But we will have, in some places, people will choose height. They'll choose IQ. They may choose athletic ability. And there's always a balance between nature and nurture. But whatever your view, whether nature is 80% or 50%, it's pretty darn important. So we're going to be making those kinds of decisions which will have a fundamental impact on the future of our species. The second thing will be, right now, average male ejaculation has hundreds of millions of sperm. But in women creating eggs, it's a much smaller number. The average is 15. But using stem cell technology that already works in animals, we're going to be able to take blood cells or skin cells, turn those into stem cells, induced stem cells, those stem cells into egg cells, and egg cells into eggs. So rather than choosing from 15 fertilized eggs, we're going to choose from 100, 1,000, and again, the cost of sequencing will move towards 0. And what is the range if you're going to have 1,000 or 100, let's say, potential kids? What's the range of height between kids that you may naturally have? What's the range of IQ? What's the range of health outcomes? And then we'll even be able to, and this is going to freak you all out, mate early stage embryos with other early stage embryos. So a 3-month-old embryo can have a child with another 3-month-old embryo. And so we could go through 1,000 years of evolution in 1 year. And think about that. Think about what that means for eliminating terrible diseases, but also for making other kinds of decisions that we will be faced with as a species. And in the third phase of this, again, all of these are technologies that in one form or another already exist, is precision gene editing. So raise your hand, who here has heard of CRISPR? So CRISPR is a new tool for precision gene editing. Just imagine you're sitting at your computer with a Microsoft Word and there's a sentence and you see a letter you want to change. You put the cursor there and you eliminate that letter and you type something else. And we can do that with genetic code. Our genetic code, food, animals, and the level of experimentation is it's mind-boggling what is happening now with the use of this precision gene. Everybody, when you go home, you should do a little bit of research on CRISPR because it's an invention along the lines at the level of importance for our species as harnessing steam power or the internet. I mean, it's really at that level. It's much bigger than a lot of things that we think, wow, that's really important, like jet travel. This is bigger than that. So I hope that everybody will study up because you'll be learning more and more about it.